All right, let's unpack an incredible story of engineering genius that's kind of hidden in plain sight. We're going to look at one of the world's most iconic towers and the secret, jagged weapon it uses to stare down the fury of a typhoon.
I mean, this quote right here, it gets straight to the heart of the mystery. Just picture it. You're designing what's going to be the tallest building in the world. And then, in a wind tunnel test, you discover that its sharp corners make it sway so violently that the very air around it could, like, tear it apart. That is a huge crisis for the engineers.
Okay, so first things first, let's set the scene. We're talking about a true titan here, a huge symbol of national pride. But here's the kicker. It was built in a place that's literally known as Typhoon Alley.
I mean, the ambition here was just staggering. At 508 meters, Taipei 101 completely shattered records. And its design, you see those 8 different sections? That's a nod to the number 8, which represents good fortune. But the location, wow, what a massive challenge. It's in a region that gets battered by both earthquakes and super typhoons. So, this wasn't just a race for height, it was a flat-out battle for survival.
So the big question is, how do you make a building that tall survive those kinds of storms? Well, the first attempt, let's just say it didn't go so well. Let's dive into what happened when that original design was put to the test.
Architecturally, that first draft was super clean, really modern, and it turns out deceptively simple. It looked strong, solid, just a massive tower with these sharp 90-degree corners, a classic, confident skyscraper look.
But this is where reality hit them like a ton of bricks. In the wind tunnel, that clean design, it turned into a total nightmare. The scale model swayed so violently that it would have been absolutely unbearable for anyone inside. And even worse, it posed a genuine risk to the structure itself. Suddenly, the engineers had a massive problem on their hands.
So what was causing this terrifying swaying? Well, it wasn't just the raw power of the wind. No, it was something much more subtle, something rhythmic, and something incredibly powerful. You could almost call it the invisible villain of our story.
And that phenomenon has a name: vortex shedding. The key thing to get here is this idea of alternating low-pressure zones. See, as the wind splits around the building, it creates these little vacuums that pull on the tower, first on one side, then the other. It's like the wind is plucking it like a giant guitar string. It's not a steady push, it's a rhythmic pull. And that rhythm, that's what's so dangerous, because if it matches the building's own natural wobble, that's called resonance, it can amplify the swaying to catastrophic levels.
Okay, so let's break this down even further. The wind flows past the building, right? And it swirls around those sharp corners. These little swirls, they're called vortices. They peel off, first from one side, then the other, in this steady beat. Boom, boom, boom. Each one creates a tiny bit of suction. But when they all happen in a synchronized rhythm, suddenly you've got this powerful back-and-forth force that can make the entire tower shake. So, what do? How do you fight a force like that? Well, the answer wasn't just to add more strength. The real solution was to completely outsmart the wind.
And this is where the fix gets so elegant. Instead of just trying to fight the wind with brute force, piling on more steel, more concrete, the engineers use geometry. They literally use the building's shape to disrupt the wind's attack. It was an incredibly clever and honestly beautiful solution.
They called it corner softening, so they got rid of those sharp 90-degree corners and replaced them with these angled, beveled edges. But here is the absolute masterstroke. They cut this unique sawtooth pattern into those edges, and the goal? It was simple, but it was genius. They wanted to scramble the airflow. By making the corners all jagged and irregular, they stopped the wind from forming those big, organized swirls. They literally confused the wind so it couldn't find its destructive rhythm. Okay, so the big question, did this simple little geometric trick actually work? Well, the results they got from the next wind tunnel test were, honestly, nothing short of a breakthrough. Get this, the result was a staggering 25% reduction in movement. Just by changing the shape of the corners, they eliminated a quarter of all that dangerous swaying. That's huge. And this chart just makes it crystal clear, doesn't it? Look at the bar for the original design. That sway potential is way up there, dangerously high. Now look at the one for the sawtooth design. That movement just plummets. That 25% wasn't just a random number. It was the difference between an unsafe, uncomfortable building and the stable, modern marvel we see today.
But here's the thing. Those sawtooth corners, they were only the first line of defense. To make Taipei 101 one of the safest super tall buildings in the world, they needed one more thing, a final, incredible anchor against the storm.
And that brings up a pretty obvious question, right?
I mean, a 25% reduction is amazing, for sure. But in a super typhoon, you're still dealing with these immense forces. So, was it really enough? Was the building truly safe and comfortable for the people inside?
The answer comes in the form of one colossal number, 660, as in 660 tons. That's the weight of the tower's other secret weapon, this massive piece of engineering called a tuned mass damper. So what the heck is this thing? Well, it's basically a giant pendulum, a massive gold-plated steel ball hanging from these thick cables way up near the top of the tower. When the wind pushes the building to the left, the ball just naturally wants to swing to the right. This counter-movement is perfectly tuned to cancel out the building's natural sway. It moves in the opposite direction, soaking up all that vibration energy and keeping the whole building remarkably stable. It's like a giant shock absorber.
And here's the coolest part. Instead of hiding this incredible piece of machinery away in some service corridor, the architects turned it into a centerpiece. You can actually go up to the observation deck and watch this 660-ton golden sphere do its thing. It's basically engineering as public art, which is just awesome.
And believe it or not, it gets even better. This supercritical piece of safety equipment is so beloved that it has its own official mascots. They're called damper babies. I'm not making that up. It just goes to show you how this engineering marvel has become this celebrated, fun part of the building's whole identity.
So I think the big takeaway here is this. When you look at a skyscraper, you see the glass and the steel, right? But the real genius, that's often hidden in the little details, the things you might just think are for decoration. And when you know the story, you start to realize that the most beautiful architectural details are often the invisible shields that can turn a deadly storm into just a gentle vibration.